Good afternoon, everyone. Thank you for coming to my presentation. Today, our topic is about the vision meets intelligence. We are talking about AI-driven optical inspection. So how we just use this concept to transforming the manufacturing. So basically, currently in the manufacturing industries, bearing manufacturing industries, we can meet several of the most important pinpoint here. First, everyone knows that is labor cost. And currently, the labor cost is being higher and higher for this industry. And second one is about the quality consistency. Bearing is using in all the industries, and the quality is very important to this. Without the quality standard of the bearing, the vehicles, the machines in industry, railway, can all have some problems. So the quality is always with high standard, especially with more high technology. So currently for the bearings, the quality is also just more and more strict. So how can we just output the consistency of the quality is another pinpoint of the bearing industry. And then it's about the OEE improvement. So this is how the bearing manufacturers, they can just increase and to make the steel just very competitive in this market. So how we can do, why we just put this pinpoint here? Because in our mind, AI is just a tool. By this tool, we need to just really just solve the problems, the pinpoint they have. So this is how we use this tool. So in our mind, so now many companies, they are talking about AI. So what is AI? AI is kind of the software, but in the manufacturing, in our mind, our understanding, AI is not only the point, the components can just solve the problem. We need to combine them together. AI, you can see like a heart, like a brain, and machine vision, just like the eyes, and also the robot control, like arms. And then we have the hardware design to make all this as a body. So the product with all this combined together can help the manufacturer to do so. We can see there are many of the AI concept and machine visions, standalone systems, but they still have some space to improve. If we just combine them together, it will be some result, just 1 + 1 more than 2. So this looks like some in the AI driven automatic optical inspection system looks like. So in the core product is the AOI inspection machine. But if we want to really just help the customs to improve their quality and also just control the cost, we need something more. Maybe the automatic loading machine and also with the washing and the drying machine to just make the surfaces very clean and to just make the quality even better for the AOI machine to reduce the false rate. And after that, maybe they still need to have some preservation machine to do it for the packaging. And so that after the production lines, we can provide all the information, all the functions for them to just complete everything. So this is also very important. The fact is here, so with all this hardware and software combined together, we can have many of the features good that, for example, recognition accuracy can be very tiny at 0.1 millimeter, and missing rate can be raised to 0. And also overkill rate is very important for the manufacturers, and it can be lower than 1%. And the CT can be very fast. And for the OEE, so we have some samples that the OEE, with all this system together, it can be more than 8% improvement. And for the labor cost, it can just reduce. And maybe 4 employees, full-time employees can be saved each lines, and others. So we come to the AI part. So how the machine vision, the AUI machine is not a, very new stuff for the customs, but why we need to just involve AI in this system? Because AI have some advantage for them. And what's that? I can just try to introduce to you. First one, with the AI algorithm, let's say we can just the false defection rate, it will be reduced by 5 to 10. So for many just irregular defects and some conflict surfaces, it will be very hard for the traditional mode to do the inspection. But by the AI deep learning system, it can be much easier to find them. So it can just reduce the false rate. And here is for the efficiency. So AI, basically, we just do it on the calculation on the GPU. So that is parallel processing. And the traditional one normally is just on the CPU. And for the single image processing speed can be up to 2 milliseconds. So it is very fast. And the full coverage of the defects and the accuracy of detection. So basically, by the AI part, it can be reduced much about the false rate. So accuracy of the visual defect can be detected in the image about 100%, full coverage. And full coverage of the detection area. So for complex surveys, before, by the traditional method, it's very difficult to set it, especially some irregular surfaces. We need to set the edge, we need to set the area. In different areas, maybe have different policy and different parameters. It's very difficult for the operator to do so. So imagine the operators, they already just have the machine in their factories. When they need to just identify some new defects, they need to set it for a long time. But here, if we have the AI part, we only need to just set the age of the areas, and we don't need to care about the different type of the surfaces. Flexibility. Flexibility is also very important. As I just say that, so flexibility is important for the operator. The defects are not just all the time the same, so they need to change. Sometimes, maybe some process getting wrong, they have some new defects. If they need the supplier to configure it, it will be a long time. If they want to just, configure it by themselves, it will also just need some much more skill to do it. But by the AI part, it's quite simple. So first, collect the image from the very beginning by the machine, and then tag it, and then put it in the different folders for the different category. And after that, to do the training, AI do the training, deep learning training by themselves, and after that, it's so simple, it's done. It can be involved, recognized. So flexibility is very important. It can reduce the time, configuration time, and the adjustment time for the new type of defect from weeks to only several hours. Yeah, this is also just what I want to say in the next part. So the time to just add a defect is only 5 to 8 minutes. And after that, including the training, is only several hours. And for the traditional method of the AOI machine, normally it's just based on the scale of gray, and it's have high dependency of on the light source. But for AI mode, it's just what you can see, what you can detect. So this is for the AI function, it can have very low dependency on the light source. So here are some details for these several parts. And the first one is intelligence recognition, reduce the false detection rate. Here, what I just have already said that through the training and the learning of the mode, AI detection can realize the intelligence identify of defects reduce the force rate on it. So this is the disadvantage of the traditional one. Here are some samples. So two very typical process of the automatic industry and also the bearing industry. First one is the heat treatment. After the heat treatment, sometimes because the temperature changes a lot, so there are many of the dark points here. For example, dark areas here. For the traditional mode, and it's very likely to be detected as some defects. So indeed, they are not, because the surface is okay, the function is okay. So, but by the AI model, we can just very easy to just know the pattern on it and to exclude it into from our gallery. That is the okay part. It's quite easy to do so. And also the same about the oil film. After the process, sometimes we have the oil film on that, and it's also just a force rate in the traditional way, about 5 to 8%. But for the AI function, we can easily just tag them. They are not any of the real defects, and then it can be excluded very easy. These are some samples. And here is the full coverage of the detection area. So we have already just explained that. Let me just check to. For the AI functions, it can be very easy to just do the full coverage. For example, here is some samples for the edge bumps detection of stamping parts. With the wear of the die, the edge accuracy of the stamp part will become worse and worse. So resulting in the traditional algorithm cannot use the same set of the algorithm to effectively segment the detect edge. So, but if we have the AI part, by the generation, they can just recognize it very easily. They don't need to change any pattern of any of the parameter on it. It can definitely just detect it for all the time. So this is some efficiency. I have already just explained it. It's by the generation. It can easily just find the pattern of the defects. Can be easy to understand. Look, so this page we see we can explain the full coverage of the defects and accuracy of detects. So there are two parts here. For the AI part, it's quite easy to just use the AI training to do the most adapt the model based on the neural network. And after the training, AI detection can just achieve the full coverage of the defects. It can be 100%. Especially for the traditional mode, there are some different kind of the way they do the detection. For example, it's always on the gray scale. By the gray scale, it can need to have at least 20 of the difference to find the defects. For example, for some green defects, if the difference is too low, even if it has some defects, it's quite difficult for them to find it. But for the AI part, it's very easy to do so because we can find the pattern on it. What we can see by the eyes, what we can see by the camera, what we can do, we can detect them. Yeah, this page we talk about the flexibility. So I can skip this because we know that it takes much shorter time to achieve that. So for this page, we talk about the strong compatibility. And for the AI detection, we can do it. AI can just have low dependency on the optical system, and the defects can be visible to the naked eyes. We can do so. Here are some samples. These samples can show, this is some parts of the wheel hub. For the wheel hub, you can see there are different layers of the surface. This is machining, is already machining layer surface. For that, and you can see there is another bolt. By the traditional way, they need to do the segmentation of the different surfaces. So for the different surface, they might have different pattern to find the the defects. But here, with the AI mode, we only need to set the detection area, the 4 points here. And then in this part, we can see this complicated in the 2 layers, but we can still easily find the black spot on it. So this is much easier than the traditional way. And also, this is what we can do now for the AI-driven AI machine. But we know that for the AI, I think we have 2 directions to help the manufacturers to do so. First one is top-down. Some AI model can help the custom to do the optimization of the whole production process. And what we do here is in the dedicated area, to help them to increase their quality. But these two methods, 2 directions can combine together. So this is why we also have just in our next step, we are doing the K2 AI Cloud. So we can just transfer our information, all the quality status to the cloud, to the centralized AI model. Whatever this AI model is the AI model of the companies themselves, or they can just do in some others. And by the main interface, you can see we can just upload all the information of different lines about the status, what's the quality now, and what patch of quality have the lower rate of the defects, and what kind of the defects just to find much more than before. And by this, and also the alarms and the manager of the factory can know exactly what's the problem with the producing lines. And even more, currently we can also just do the centralized training of the AI. First, some factories, they are very strict to their security, to their network. So they want the AI to be only trained in their local system, in the machine. So this is what we are doing now. But now, with the concept of the Industry 4.0 and the smart manufacturing, more and more customers, they are thinking if they can just do something centralized. So this is what we will do next. We can do the AI training in the centralized server and then dispatch them to the lines. So this will save even more time for the customers. For example, if you only need to do this, then you only need to spend maybe 5 to 8 minutes in the configuration to involve the new defects. And after that, the training can be in the server. This several hours is only just in the server. Your machine can still just running. The producing is still running. And after that, when the training is finished, you just dispatch them to this machine. And even more, you can just share it to any other lines. So it will be more efficiently. And these 2 pictures, screen copies, can show how we do the AI offline training in the central server. So I think for all our AI functions here can really just help the customer about their production and get the quality more consistent, and also to just save their cost for the labor. Yeah. Thank you to listen to my presentation. Yeah. Here are some page of our company. We have already just done it, established from 2009. And until now, we have already just supplied many of the top customs in this industry. This is customer reference, what we have. Yeah, thank you.